On today's episode, SpaceX wins a big NASA contract, windows made of wood, and moving to model-based design in aerospace. Today's episode is brought to you by engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on engineering.tv today. NASA's Gateway program will create the first long-term lunar orbiting space station to support lunar missions under the Artemis program. The agency's announced that Elon Musk's SpaceX has been chosen to launch the two core elements of the Gateway complex, the Habitation and Logistics Outpost, or HALO, and the Power and Propulsion Element, or PPE. Both modules are integrated on Earth, and they'll be launched together at an earliest launch date of May 2024 on a Falcon Heavy rocket based at Launch Complex 39A at NASA's Kennedy Space Center in Florida. That famous complex was the starting point for the Apollo 11 lunar landing mission. The PPE, built by Maxar Technologies, will provide power, communications, attitude control, and solar electric propulsion to allow Gateway to move between lunar orbits. The solar panels will generate 60 kilowatts of power. The Northrop Grumman-built HALO is the habitation section where the astronauts will work. HALO will supplement life support systems aboard Orion spacecraft scheduled to deliver Artemis astronauts to lower lunar orbit. The idea is to create a way station for crews visiting the moon, as well as providing a research platform for related science experiments. The Gateway program is managed at NASA's Johnson Space Center in Houston, while the Large Services Management program will be operated by NASA at the Kennedy Space Center. Total cost to NASA is estimated at $330 million, including launch services and other mission-related costs. Reasonable. When architects or engineers need transparency, the choices are few. Usually it's glass or polymers. Now that may be changing, however, with new research from a team led by USDA Forest Products Laboratory researcher Junyong Zhu. Zhu, working with a team from the University of Maryland and the University of Colorado, they developed a transparent composite material based on wood that might have multiple applications in civil and mechanical engineering. The team used a balsa substrate, then treated the wood with hydrogen peroxide to oxidize the chromophores present in the wood that give it its natural brown color. Impregnation of the wood cells with a polyvinyl alcohol resin matrix creates the refractive conditions necessary for optical transparency. Early results look very promising, with optical transmittance of better than 91%, 3 orders of magnitude better toughness than glass, and a thermal conductivity 5 times lower than vitreous materials. Essentially, transparent wood is as clear, much stronger, and has better insulating properties than conventional glass. Now, research is in early stages, and it's unclear whether the process can be scaled into commercial volumes at competitive cost, but the team notes that the material has a low carbon footprint in production, and it can be cut and shaped using conventional woodworking tools and techniques. If this can be achieved on a commercial scale, it could fundamentally change the way architects and engineers think about construction. For centuries in engineering and millennia in civil engineering, drawings have been the basis for design. Computer-aided design made those renderings virtual, but in concept, drawings have changed little in decades. The aerospace industry, however, may be about to change that. An industry team from multiple companies, the Aerospace and Defense PLM Action Group, they've released a report that defines how the industry can move from renderings to 3D model-based representation for type design certification. The group issued a list of detailed requirements for the minimum dataset needed to achieve parity with conventional CAD-based systems. Founded in 2014 and originally intended to act as a liaison team between the aerospace industry and large PLM vendors, the group includes representatives from all major airframers as well as engine makers such as Rolls-Royce, GE, and Safran. The study outlines use cases and basic definitions to standardize model-based definition at major OEMs. Over 200 specific data items have been identified as a basic minimum for usable 3D modeling for aircraft certification. The work is important for cost and safety reasons and to address a critical problem in both civil and military aviation today: time. In civil aviation in particular, airframers and engine suppliers are having difficulty bringing products to market in time to meet customer needs. It's possible to build a successful product only to find the market it serves has disappeared by the time production aircraft reach customers. Faster time to market can be facilitated by advanced design tools, and this collaboration should help address that issue. The report is the result of 2 years of work from the team, which included both major OEMs and important Tier 1 suppliers. Well, that's it for today's episode of This Week in Engineering, brought to you by engineering.com. If you like this show, be sure to subscribe to our channel and click on the notification bell for our next episode. For deeper engineering content, visit engineering.tv for exclusive shows not found in our YouTube channel. Thanks for watching.